For question 12, we're given the question, does f of 1 exist? So I can either look over here at the algebraic function, or I can look at the graph. If I look at the graph where x is 1, there's a dot filled in, the y value is 1. If I look at the function, there is a rule of what to do when x equals 1. It says to make y equal to 1. So yes, it exists. Does the limit exist? Well, the limit at 1 exists. If they don't put a directionality on it, you have to approach that 1 from both sides and see if it's going to the same place. If I approach 1 from the left side, then I get closer and closer to a y value of 2. If I approach 1 from the right side, I get closer and closer and closer to a y value of 2. So regardless of which way I'm approaching 1, even though I'm on different lines, they have different slopes, as I get close to 1 on either side, the y value is 2. So that limit does exist. It equals 2. Does the limit as we approach 1 and the value at 1 match? That's what this is asking. As I approach 1, as I get really, really close to 1, when I'm actually at 1, are they the same value? The answer here is no. This got closer and closer and closer to 2. This is actually equal to 1, so they don't match. And because they don't match, I would know for like just symbolic manipulation style, I know that it's not continuous there. Or if I use my eyeballs, I can just see that I had to pick up my pencil and move a point down here. But I'll just say, like, if I didn't have this graph at all, I just had this equation, and I had this question to think about, I would have to consider, like, this rule and this rule with x equal to 1, since I'd be close to 1 on both of those. And plugging 1 into either one of these would spit out a y value of 2. So I'd be like, well, the limit exists, and it equals 2. But if I were actually at 1, the y value is 1. So even if I didn't have the graph, I can use the equation to say it's not continuous, because as I approach 1 from either side, even though I'm going to the same y value of 2, when I'm actually at 1, y value is something else. That means still hold the graph. Good times.